Okay, I'm going to show you how to run a linear regression on the Desmos online calculator. So of course you want to go to desmos.com and launch the calculator. Here is the data set that we'll work with. This is all the winning pole vault heights in the Olympics. So the year of the Olympics and the winning height. I want to recognize some trends. So what I'm going to do is come here to add item and a table. That's where I have my data. So X and Y, I'm going to come here. Years is my independent variable. The height is my dependent variable. So I will put years in for X and the heights in for Y. So as you can see here, you can just go in and type them, and it will work. So here is my data, and here it is on the calculator. There's clearly a problem here. I need to adjust my window. So how I'm going to do that is by going here to graph settings, and I know my X values are between 1900 and 2000, so I'm just going to change that. Actually I'm going to start a little bit before 1900, so let's start with 1890 to 2000. Those are my years. And my Y values, my heights, go from about 3.3 to 575. So I'm going to change that to 3. Let's just start at 0 since it's not bad. And we'll go all the way to 10 so we can see a nice jump. There we go. Now it looks a lot better. So I need to run a regression. You're going to add another item, expression, and that will add another box. I want this to be a linear regression, so I'm going to add a linear equation, a general linear equation. Which general linear equation are we familiar with? That is the slope-intercept form. Y equals mx plus b. I want a line, but I want to use this data, and I want it to model it. It's not going to be equals because it's going to be a model. And so we're not going to use an equal sign. What we are going to do is hit Y, and since I want to use this data, I have to say Y1. So just hit 1 and it'll put it down there for you in the subscript. And again, it's not going to be equals because this isn't an actual straight line here. I just want a line that's going to model it. So instead of using an equal sign, I'm going to use this little squiggly sign here that you can find above tab. Shift and the button above tab will give you that. And then mx, but I want to use this data set here, so mx1, because I want to use these x's, and then plus b. And you can see it gave me my line of best fit here. That's exactly what we want. If I had made a mistake, I'll show you what happens if you make a mistake. Say I didn't say, okay, use x1, it's going to say, and it says, x may not be used as a regression parameter. It says, okay, I know you're trying to run a regression because you use this symbol, but I don't know what data set you're talking about. So you have to come here and say, okay, I missed this one. And it'll tell you that. So here it gives you your equation. This is m, and this is b. So if I wanted to write the equation of this line here, I would say y equals 0.02-ish, I'm just going to round, x plus, or I guess it's not a plus, it'll be, since it's b is a negative number, it'll be minus 45 0.2. And that would be my equation for this line here. So what does that mean? Well, m is the slope. So that means every year, so every one jump in year, I'm going to go up 0.2 meters, 0.02 meters, 0.02 meter increase in pole vault height every year for the Olympic winner. So now that we have this line, we can use it to predict things. Like say we wanted to know in 1940 there wasn't an Olympics. Why wasn't there an Olympics? That's because it was World War II. So if I wanted to ask myself, that might be a strange question, but what would the pole vault winner be that year? What do we think it would have been? I can come to this line and click and say, okay, well in 1940, it probably would have been around 4.4 meters. A more realistic question that you would have asked, that you might want to ask yourself is, what about if you're a pole vaulter and you're going to be in the 2020 Olympics and you say, okay, what do I have to train for? What should I expect a winning pole vault to be? So you can come here to 2020 and say, okay, I probably have to train so that I can get to about 6.4 meters. And say it's a pain and you wanted to predict very far in the future, what you could do as well is just say, okay, here are my parameters in this. So I can just add in an actual equation, y equals. And now that you have this equation in here, that's the black one, that's why it's black, is different from the orange. You can come up here and say, I want to convert this to a table. Now you can put in any year you want, and then we'll just tell you. Let's say 2300. You can expect 13.6 meters. Eventually, a model like this will probably be a little unrealistic. Let's say in the year 3500, are we going to be pole vaulting 44 meters into the air? Probably not. You never know, but you have to take these models for what they're worth. Models like these tend to be better when you're closer to what they're predicting. When you're really far down the road, it can be skewed a little bit. But yeah.